also our moderator, Mr. Essa Rahemi. I hand over the mic to Mr. Rahemi so he can go ahead with his session. Thank you very much.
Thank you, Ahmed Khelsep. Salam. Good morning, good afternoon, good evening, everyone. Welcome again to this session. I hope I will moderate in a very interesting way that we can engage with the audience. So today we have our speaker, Mr. Tashi. He will speak about coding your network, which is really interesting. I want to know more even myself. So Tashi has been working in the internet industry since 2004. Tashi is currently working as evangelist optics, I think, maybe if I pronounce the name correctly. So he is, I think, the team lead for the Asia Pacific region. He will be talking again, so for coding your network. So we are going to deep share insight and learn from Tashi about coding your network. So feel free to participate actively and ask your question. So we will try our best to answer your question. So also at the end of the session, we will have a dedicated time for the Q&A. So where we will be able to better answer your question. So hello, Tashi. So I'm transferring to you. So you can start.
Thank you so much. Assalamu alaikum, everyone. Can you see my slides before I kick off? Yeah?
Yes, we can see.
Yes, we can see.
Okay, thank you so much for confirming. I'm trying to share two screens. I apologize if I'm not that well prepared. In between multiple trips, I'm a bit jet lagged. But without much ado, yeah, thank you for the introduction. As many of you know, I also used to run a network for, I was the head of network for Bhutan Telecom before I joined APNIC for a few years and now with Flex Optics. I would like to thank the FNOP team, especially Mohibullah, for inviting me to deliver this talk. I hope I do justice to coding the network. I have interpreted the session title to my own need. I apologize if my interpretation of the session title is not right. This talk is not a lecture or me telling you what I know. It's more about my understanding of what I understand by programmability and what I understand by coding the network. Hence, it's an attempt to demystify the concept. Please let me know if you can. Now, a quick disclaimer. I don't know how many of you know Mercia. Mercia was a good friend when I was in APNIC. I requested him. We co-developed the APNIC automation workshop with him. Mercia was at Cloudflare at that time. That's why you see his book was written when he was at Cloudflare. But now he is the automation lead and the chief architect for automation at DigitalOcean. So my message is, if it works for Cloudflare and DigitalOcean, I'm sure it will work for many of us, the ideas that he has shared. Anyways, let's start. I will try to give my talk in two different ways. I'll first talk about the SDN architecture framework before I jump into modern concepts of orchestration versus automation and programmability, what we understand by that. Looking back at, just before we go any further, just looking at the fundamentals, it's very important to look at the role of a router. Right? Many of you are familiar with this, but what is amazing to note here is the role of a router hasn't changed from the ARPANET days. In the ARPANET days, we didn't have routers, we had IMPs, right? Interface message processors, whose job was just this too. Basic functionality is just to tell me the path from A to B and then forward my packet from A to B. And routers haven't changed their fundamental role, right? But when you look at a modern router, although the basic functionality of a router hasn't changed, its complexity has changed, right? And why did this complexity change? It's because nobody would have thought, from the early days of the internet when we were just carrying text-based content. When I joined Bhutan Telecom, we had only dial-up services, 4 meg of internet for the whole country, right? And that time, what were we doing? Text-based chat rooms, IRC chat rooms. So the content wasn't that heavy. Applications we were carrying wasn't that heavy. Telecom was still dominating. Nobody would have thought that modern days, this whole global communication running over an IP network. Hence, you see today's routers have become very complex for us to be able to carry from the early text-based communication that World Wide Webs and to this concept of voice, multiplay, and then to what it is today, where pretty much the whole of global communication happens over the IP network. And to support that, our routers, although the fundamental role of, again, determining a path from A to B and then forwarding a packet hasn't changed, its complexity has changed. We have very diverse management features, right? We have high availability features. We have different service layers. We have elaborate, complex QoS mechanisms, as you can see. And then in most of the modern routers, we have very specialized network functions. We have specialized hardware to carry out for specific network functions. So what did we end up with? In the end, we have ended up with a very closed, expensive box that we call a router, right? I don't know if anyone of here has shares in Cisco or Juniper or Huawei. Unless you have shares in those companies, it's not a good ecosystem. It's a vendor world, right? But how did we end up here? Before I go into how did we end up here, just a quick recap, right? I'm sure everyone is very much aware of the multiple planes, but there are certain key points I would like to mention here. Everyone knows control plane, its primary job is to determine the path. Data plane's primary job is to forward the packet based on that, what the control plane tells you. And the management plane, of course, is to manage the device and the functions within the device. But if you look at the control plane, the good thing about the control plane is what? The control plane, think of it as your routing protocols. Let's say BGP, for example. The good thing about the control plane is it is developed by standard development organizations, SDOs as we call it, or IETF, for example, right? And the good thing about that is it is interoperable. BGP should behave the same based on the RFC, whether it's a Huawei box, Juniper box, Cisco box, or Arista box. So control plane is great. That's why many of us, people like me who runs open source routing suits, like I run Burn, I run FRR, I'm able to run the control plane parts, right? Because that is open, it's backwards compatible, and it's interoperable. The problem is the data plane. Right? The problem is the data plane because the data plane is very, very hardware dependent, which means it's very vendor specific, which means it's a very closed environment. I don't know how many of you have tried to build your own routers, right? I have tried to build my own routers on a server, on a NUC. Control plane part is always easy, but the forwarding plane, we can never beat the vendor. I don't have the hardware expertise to build a forwarding plane, which is hardware dependent, that can forward packets at the same line rate as a vendor device can. Right? So that is the biggest problem of networking, where the data plane is a closed environment, right?
So
And
just to
then,
stop you here,
yeah,
Tashi. So as I
yeah,
understood, so you mean that you're not really dependent on any vendor. So you're more like a technology neutral person, like where you can build whatever you like, you can build based on maybe open source technologies and stuff like that. You're building your own router, which is amazing.
correct. But that's the sad part. We cannot, the control plane is great, right? The routing software is great. Anyone can build it, you, me. But then you come to a standstill when you look at the line, the forwarding rate,
Yeah, the
because you need a
plan.
hardware. You need a really good hardware. And the hardware is people like you and me. We are not hardware engineers. So we then, example, if a Cisco router can do 7 terabits, I cannot achieve that on a server, right? So that is where the vendors always win, and that is where the biggest problem is. It's the data plane where the biggest problem is. And as you can see, as I build my SDN framework and automation, we try to manipulate that data plane. Let's see how we do that, right? So that for me is coding the network. For me, coding the network is, can I push a behavior in my network the way I want it? I don't want a routing protocol to tell me, example, BGP says, oh, use this attribute. OSPF says, use this. But the actual attribute for you and me is what? Packet loss, latency. So we should be able to push the state in the network the way we want it. So that for me is coding the network. But I'll come to that later. Thank you. And then the management plane is very unique, right? There are open source, like open standards like SNMP, which is available on Juniper, which is available on Cisco or Huawei, and it's a open standard base. But most of us interact through devices using what? CLI, right? Cisco has their own CLI. Juniper has their own CLI. Huawei has their own CLI. Hence, many of us end up with certifications on their platform, right? I am Cisco certified CLI guy. I am Juniper certified. So many people come up with a piece of paper that tells me, hey, Tashi, I am Juniper certified. What? A CLI do. Right? Because Juniper has their own CLI, because that's the only interface through which I can interact with the device. This concept is critical, right? When we talk automation, when we talk coding the network. So it's a very closed world, is what I'm trying to say, right? Now, how did we get here? I think before I go into what I want to talk about, I think it's good to just step back and think, why did we get here? Right? First one is what I call the distribution of complexity. In engineering, whether you, me, or anyone, electrical engineers, software engineers, or even telecommunications engineers, what do we do when we have a complex problem? We use the concept of hierarchy, right? What does that mean? I try to break a big problem into small manageable pieces, and then I try to solve the small pieces without me solving the bigger problem. So that is done so that, uh, and then you apply the end-to-end principle to it. And then what did the early internet fathers like Randy Bush and others do? They said, okay, instead of me building one intelligent core and then dumb edges, let me distribute intelligence to the edges. If you look at our routers now, my core router might be a very expensive box, but my edge router sitting in a access router sitting somewhere else, which might be cheap, still has intelligence in it, right? That means if that box fails, my other parts of my network are still running. So that's how we distribute complexity, right? That's how we try and distribute risk, right? So that's one, distribution of complexity. So that's the need for us to push intelligence across the network. The second one is what we call backwards compatibility. When was the last time you guys ever shut down your network, told your customers that, hey, I have this beautiful new protocol I want to develop and deploy, but come back to my network 6 months from now because I need to first deploy the feature? We cannot do that, right? There is no concept of a flag day in modern networks. The only time a flag day ever happened on the internet, can anyone remember that? Maybe most of us were not even born when that happened, right? When the internet moved away from NCP, which was the network control program, to TCP/IP. That was the only time internet was shut down and a new protocol was deployed. So that was the only known flag day on the internet. There was no other flag day, which means whatever new features I need to deploy it on top of the existing ones. Right? It's always slow incremental deployment of new features, new problem solving techniques. Right. So there has been no major change on the internet since the move from NCP to TCP/IP. And of course, the third one being internet. Nobody would have guessed, not even Vince Cerf, when he wrote TCP/IP, that internet would one day end up becoming the main communication um, infrastructure for the globally. Right? So a victim of its own success, which means right from like I said earlier, from text to videos now to pretty much every form of communication and application running on the internet, you end up building a very complex network, right? Which means we need higher performance, right? I, as a user, complain to my ISPs. My ISPs might be complaining to their upstreams. They complain to their vendors and say, hey, I need better performance. I need better throughput. I need this kind of switching capacity. But what does that mean? For you to achieve higher performance, we end up with this tighter coupling of the control and the data plane, a tighter coupling of the hardware and the software, right? And you end up with a more closed environment where openness was sacrificed, right? So that was what, so I wanted to reflect on that one so that everyone can just take a pause and then reflect on why did we get where we are today. So let's look at in 2016, something unique happened, right? Stanford University, some researchers came together and they say, all right, based on the lesson learned over the last 30 years, if we are given a chance to redesign the internet or a global infrastructure, how would we do it? They called it the Clean Slate Project, right? And one of the flagship projects of that project was what's called the Internet Infrastructure, Open Flow and Software-Defined Networking, right? Again, software-defined networking, I just don't like this word, right? Personally, I like what Dr. Philip says. I don't know how many of you know Dr. Philip. He says still does not SDN, right? So please, let's not use the word SDN so much. Let's focus on programmability. So what came out of this? What came out was this.
Yeah.
Yes, please.
First,
Yeah, please.
I think a question comes again here. So, and we are Now moving forward to a clear path, like the understanding of the people, like from coding your network, there is two areas which are a bit separate. For example, one is we can also understand and think, maybe imagine coding when it comes coding your network, that maybe the SDN word where is, for example, involve the SD access, SD-WAN, and the
Hmm.
SCI. And another thing is like the pure programming, which is, for example, the network automation, where you're building your own script and run it without any management tool, for example, that we have in the SDN. We have that, for example, the DNS Center Catalyst
Correct.
or the Catalyst Center from the Cisco, for example.
Yeah.
That's also running our automation, but that's more in the managed way, if I understand. So
Correct.
we're going to talk about the programming, correct?
Yes, we will. Right. I'm trying to build a story so that everyone can come along the journey with me. Right. All right. Thank you so much for that. So, like I said, I think this open flow paper is the first ever attempt at trying to rethink how networking is to be done, right? No more CLI based work. No more Tashi having to getting Cisco certified, Mohib having to getting Juniper certified, you having to get Huawei certified, just because interfaces are closed, right? Huawei CLI is a closed CLI, Cisco CLI is a closed interface, Juniper CLI is a closed interface. How do we come up with openness so that, example, if I know BGP, I should be able to run BGP without knowing a CLI of any device, right? Um, if I know ISIS, if I know anything network standard, I should be able to run it on any device, on any vendor, without me having to understand what their CLI is. You get my, that's my key message here. Now let's see how we achieve that. Right? So what did OpenFlow try to achieve? Because the researchers at Stanford University said, even if we develop a new protocol, how do we run it in a production network? They try to run it on servers, they try to run it on open source tools. But like I said, while the control plane, you can run it, the data plane, they will never get the throughput that vendors have. Right? I will never get a switching capacity of 7 terabits on my server. I might need 1,000 servers to achieve what one router can do. Right? And if they try to run it on a proprietary Cisco, Juniper, Huawei, Arista box, those vendors will never open it up for me to run my open protocol. So you're caught in this dilemma. The researchers were caught in this dilemma. Right? So what did they try to do? I really like what OpenFlow tried to do. Right? So first, it's not a new idea. They said, okay, let's decouple the control plane completely from the box, push it into an external controller. Great. It's not a new idea, but decoupling the control and data plane is not a new idea. I used to be a telecom engineer, and we always had separate control planes, separate data planes. You call it line card, you call a route processor. Those decoupling was always there. But pulling it out of the box, pushing it to an external controller was a new idea. And for me, the most important idea was the second part, which was the data planes are very proprietary. Cisco, theirs own, Juniper, their own. So I like what the Stanford University guys did with this Clean Slate project. They said, let's apply a layer of abstraction on the data plane. And that abstraction was done through what? Through flow tables, which means I might have a network across 7 continents. It might be a multi-vendor network. I don't see them as Cisco box or Juniper box. I only see them as flow table. Well, that's my whole network. That's the abstraction that I'm talking, which means now for me as the administrator, interacting with my network, all I see is flow tables. For me to inject flows, it becomes relatively easy. So that abstraction idea is beautiful for me. And we use that idea now in modern automation. So please keep that in mind as I build my concept, right? Abstraction using flow tables. So this was a beautiful idea. But like I said, decoupling the control plane from the data plane is nothing new, right? And having one controller control one data plane is nothing new again. My router currently, your router currently does that. Your control plane controls one data plane. So we call it the 1:1 correspondence, right? But the power comes when I take it externally. When I take the control plane externally to a controller, then I'm able to control more than one data plane. All of a sudden, we move to what's called the 1:n correspondence. All of a sudden, sitting somewhere centrally, I'm able to look at my whole network, and I'm able to interact with my network, not just one control plane interacting with, sorry about my animations, I should have killed the animations. So this is what I'm trying to talk about. So from a 1:1 correspondence, we now ended up with a 1:n correspondence where one control plane is able to talk to more than one data plane. And this is the power of abstraction, right? And this is the power of that decoupling of the control plane and pushing it to an external controller. And this allows you to do a lot of magic. This allows me to push state into my network. This allows me to dictate how my network should behave, right? So OpenFlow today, I don't like OpenFlow because it's good for a campus. It's not good for our ISP environment because like topology discovery uses LLDC. It doesn't scale. But in the early days of SDN, 2016, 17, 18, 19, when I was in 18, oh, SDN was OpenFlow. It is not. OpenFlow is just one of the many technologies that fit into the SDN framework, right? So takeaways, please. Summary of my OpenFlow talk: decoupling of the control plane and the data plane and pushing that control plane to an external controller, and then abstracting the data plane in flow tables and allowing 1:n correspondence, right? But please remember, people say, oh, Tashi, what happens that if you extract your control plane to a single controller, and if your controller fails, then your whole network is down because what you are left with is dumb network. And if your flow entries in the network expire, then you can't forward the packet. Packet comes, I look up, oh, I don't have a flow because the flow has expired. I don't know what to do. I drop the packet. Right? So people say, let's have multiple controllers. But the problem with multiple controllers is, are you able to have the same state? I don't want one controller. Maybe Mohib is controlling that. Essa, you are controlling the second controller. Mohib's controller pushes a state. Your controller opposes that state. So you need consistency across multiple controllers. So those are the complexities that we come into as we have more and more redundant controllers, right? So as you can see, now I'm going into the birth of SDN, right? So the separation of control and data plane was a compromise that they made, but it allowed us to now bring in an era of programmability. And I already said this from the onset. Programmability for me is not about programming the network. For me, it's about injecting a state in the network that I want, that my customers need, right? If this latency is high on this link, I should be able to reroute things across that link. If the packet drop on this link behaves weird, I should be able to go, if Google, let's say over this IX that I'm peering with Google, if the latency looks weird, I should be able to pull Google's traffic from another location that I have a connection with them. So for me, that is programmability, for you to be able to inject a state that you want. And the term SDN was written by a journalist. That's why I don't like the term SDN. No technical person called it SDN, but a journalist who was reporting on the Clean Slate project, please read that article. He said, oh, software-defined networking. We always had software-defined networking. We always had software on the routers. It's not like we never had software, right? So quickly moving on, today's model is what? A very tightly coupled control plane and data plane. OpenFlow wanted a complete decouple, which is not realistic. And then if you look at modern networks, you still have some components of control functions that are sitting on the control plane. And wherever we can take away, like example, why would I want to take away ISIs and others away from the router? But I would still want that to remain there. But there are certain control functions that I would like to get out of the box and take it to a controller, like traffic engineering maybe. Right? Let's have a look at that. So let's try and find SDN, right? The Open Network Foundation, what did they say? Oh, the physical separation of control plane and data plane. And that's a very naive and a narrow definition of what SDN is supposed to be, right? And like I said, please, vendors keep using it. It's like how AI and ML is now getting misused. Quantum is getting misused, right? In the last 5 or 6 years or 8 years ago, SDN was so misused by the vendors. And hence, you say, we hear things like, oh, we have SD-WAN. Sure, we had hub and spoke long time ago, right? Oh, I have SD access. Yes, sure, we have overlay concepts long time ago, right? But modern concepts of all these terms related to SD is a big marketing tool from the vendors, right? So what is SDN? For me, you may agree, disagree, doesn't matter. For me, SDN is about what? It's about agility. What is agility? If a state in my network changes, I should be able to react as quick as I can to that state change. That for me is agility. And how do you achieve that? You achieve those through event-driven automation. Mohib and me, just last week, I was in Germany with Mohib, and we were just discussing. For me, automation is getting misused by many engineers now. Oh, I can spin up config. Automation is not just configuration management. Right? Automation for me is I'm talking to you guys right now. If my network is having a problem, it should be able to fix itself. That for me is automation, reacting to state changes in the network. Right? Hence the word event-driven automation. Right? And how do you achieve that? You achieve that through open interfaces. You need a layer of abstraction where I don't need your CLI. I should not have your CLI. Give me something else, which is an open standard, which is an open interface through which I should be able to interact with the network. Right? Then there's concept of disaggregation and abstraction. Disaggregation is what? I should be able to break up your box and look at its component parts and say, let me disaggregate this box, and I want specific functions within the box to be controlled by me. And that layer of abstraction is so crucial. Like in OpenFlow, what was the abstraction? It was flow table. In modern networks and modern routers, what kind of abstraction can we do? I'll talk about Yang. I don't know how many of you have heard of Yang, Y-A-N-G. So in the modern day, we use Yang as an abstraction technique, right? And of course, centralization. Then once I have managed to do this abstract my whole network, then I have some intelligence sitting somewhere on a controller or a server somewhere from where I have full visibility of my network, right? So if you want to go the path of SDN and event-driven automation, you need to make sure your controller or your automation box knows the actual physical topology of the network, and we call the topology discovery. Like I said, in OpenFlow, what were they using for topology discovery? LLDP. It works if it's in a campus or a data center, but if I have a network across 7 countries, 8 countries, LLDP is not going to work for me. So you need better topology discovery mechanisms. I would like to take a pause here, please. Let's not say SDN, right? I just don't like that word, right? And I think vendors misuse it. So with that, let's look at the SDN architectural framework. I don't know why ITU is involved. ITU always gets involved where they don't need to get involved, right? And wherever ITU gets involved, things don't work well. I'll be very blunt. Look at the telecom days. They messed up the whole telecom. That's why 3GPP people are still hangovers from telecom who still want to make money, spectrum licenses money. Even ITU tried to attempt to come up with the SDN framework. And how do I put this? Although I like abstraction, look at ITU's framework. It's too abstract. There's no information out there. They're like, hey, you have this application layer, you have this abstracted SDN controller, and then you have network resources. I like the idea, but it lacks detail, too abstract. So I'll not waste my time here, right? Then IETF came up with SDN framework, right? Architectural framework. I like this a bit better. So down below, you have your actual physical network. And like I said, it could be multi-vendor network, right? It could be any vendor that you want so that you're not locked into one vendor. But then you apply a layer of abstraction on top of your physical network, right? And then you feed that abstracted view to your network services. What are your network services? Network services could be, if Mohibullah or Essa, you're my customer, and if I'm an ISP, I give you a portal to create your own service. You don't have to talk to me, right? You just on the portal, you do that. That controller, that network service application pushes this down to my controller. My controller then talks to my network and provisions the service without me, the engineer, having to touch the box, right? So I like the idea of where IETF is going with this. And this is, I think, a more practical SDN architectural framework. The same concept that IETF used, right? Where you still have the application layer, where you still have the controller layer, and then you have the physical data plane. And then now when you look at the data plane, and this for me is the hybrid model, right? You don't take away every control function away from the box. You still need to keep some control functions in the box, right? Example, your routing protocol, OSPF, ISIs. Why will I take out my IGP? Because my IGP is what actually forwards the packet. It's a topology-based protocol, right? I still need one router from this side to know how to get to another router in my network. I don't need to pull that out and put it in my controller, right? So you need to think of that, right? So down at the data plane, you have those, right? You have newer techniques like segment routing. I know tomorrow there is a session on segment routing, right? A very beautiful idea. Although some people argue like, oh, it's source-based routing. No, it's not source-based routing. It borrows the idea of source-based routing, right? Wherein in segment routing, my box does not need to remember states, right? I push the state into the packet headers, but as the packet goes through my network nodes or routers are able to interpret the instruction in the packet on what to do with those packets, right? So you have the path computation element, as we say, PCC, right? Path computation sitting down there at the data plane. You, of course, have your traditional interfaces like SNMP, where you have MIBs, you have your flow tables based on open flow. And to provide an abstraction of that physical thing to my upper layers, I have what's called YANG, right? YANG is an open standard, standardized by IETF, yet another next generation. Look at the name of YANG, right? IETF goes quite wacky sometimes with names, and they spend 3-4 years just debating the name of a protocol instead of working on the protocol, and they end up with something like YANG, example as abstraction tool. And then you have the control layer. So that's the southbound. Now, if you look at the southbound interfaces from the controller down, what did I mention about OpenFlow? I mentioned about OpenFlow. When I was talking about OpenFlow, I was trying to say that I don't like OpenFlow's LLDP as a topology discovery, because my controller could be sitting somewhere. My network is across the world. How do I get the topological view of my network? Now there are smarter topological discovery protocols called BGP-LS example, where I carry link state information, which is the topological information, as a new NLRI inside BGP. And many of you know what BGP is. BGP is a TCP-based protocol or a session-based protocol, which means I don't have to be physically connected to the controller. As long as I have connectivity to the controller, I am able to feed the topological information to the controller through a new protocol called BGP link state, right? And if there are state changes, I'm able to, so that's topology discovery. And then if I need to inject state into my device, I can use what's called I2RS, which is into the routing system, right? You're able to inject the on-demand state as you want. If you want to do traffic engineering, from the controller, you can use open interfaces like Path Computation Element Protocol, PCEP, right? Where I can push segment routing instructions down to a segment routing capable router, right? And then if I want to make configuration changes, example, like I said, event-based automation, if something has gone wrong in my network, if it sends it back to me, the controller, I want my controller to be able to make configuration changes on my device without me as an administrator interfering with that one. And that can be done through the NetConf protocol, right? So for me, this is a more practical SDN architecture framework. And if you want to know some open source projects, I've used Open Daylight as a controller, ODL. I don't know how many of you have used. I'm sure pretty much many of you would have used the Open Networking OS. Now, a summary of SDN. Please don't buy into the hype, right? It's not a revolution. It's a tiny evolution. The ideas have been borrowed from many different problems that we have in the past. There is no one single protocol, as you can see, right? It's a mix of protocol, right? It's a mix of protocol. So please consider that, right? SDN is not one technology, right? It's a mix of many, many pieces that you fit into our architectural framework and make it possible. So that brings me to the end of my SDN talk. I will use another 10 to 15 minutes to talk about how do you use that idea of that framework and do modern automation. But how do you code the network or inject a state into the network, right? I borrowed this from Mercia. Many modern engineers, I don't know, even those of us in this room, even on this panel, I think we are guilty. Oh, I use Ansible to do this. I use Puppet to do this. I use Python to do this. That is not automation. It's orchestration, right? So we need to differentiate what is orchestration and what is truly automation, right? And now, before we talk automation, for me, it is very important that we first understand how to abstract the network, right? Example, if you look at a Cisco box, the way they call their interfaces different. Cisco says it differently to Juniper. Huawei says it calls their interface modules very differently. But if I use Yang, which is a data modeling tool, right? And Yang is not XML, it's not JSON, it's not YAML, right? Yang is a data modeling language wherein I'm able to standardize, I'm able to structure. Interface should be an interface. Memory should be memory. But if you look at a Cisco box, oh, interface this. But when you look to Juniper, oh, go into this module, go into that submodule. That's how they interpret an interface. So it is too confusing for engineers um, to master those things. So Yang is a very, very important tool if you want to do automation. Right? Here is the example of Yang. On the leftmost side is the Yang model. Example in this one, I'm trying to talk to a device. And within this device, you see, I've tried to abstract it, right? I have a tree structure there where I say, I need this data and I want it in this format, right? And here is a NAPAM structure of the same Yang model where I say, okay, go into this device. If I want to see interface, I should be able to see all the interfaces on this device, but in a very structured manner. And then using this Yang data structure, if you like JSON, go ahead, use the JSON format. If you like XML, use XML format. If you like YAML, use YAML format. Completely up to you, right? But we need to agree on the Yang data model first. And this was what Mohib and I was talking last week. Oh, automation is all about config management. I am so sorry, those of you who believe that. I can debate with you for ages, for hours and hours, why automation is not about config management, right? Not just about config management. For me, automation is a bit more than config management, right? It needs to be event-driven, right? Something happening in my network, I should be able to get that information and I should be able to react. How many of us in this room fly? Right? We all fly on plane. Imagine if pilot gets information from the wings on SNMP, 5 minutes delay, right? Hey, here is the MIB or object ID. By the time the pilot reacts, the state of the flap has already changed. We might fall right down the sky. But in the sky, in aeroplanes, pilots get telemetry from the flaps, from all the parts of the aeroplane, right? So when we talk of automation, we need to look at it from that angle. And our network keeps giving us information, right? How many of us look at syslog messages? We need to look at syslog messages. There are SNMP traps that keep coming. There are many devices that are now capable of giving me telemetry information, right? So these are some of the tools or the information that we receive from the devices through which we can automate the network, right? In this example, because the talk is short, I will stick to, and I haven't built a lab, I just have some demo screenshot. Let us focus on a syslog message as an example on how to do event-based automation. Look at the syslog messages. One is from Juniper, one is from iOS XR. Can anyone tell me what is weird about this syslog message? They don't look the same. Juniper has their own style of doing syslog messages. Cisco has their own style of doing syslog messages, but I am the same guy who needs to interpret that, right? So you already see two different syntaxes of a syslog message from two different vendors, right? So how about I use some abstraction tool or some structured tool? In this example, I'm going with NAPAM log, right? Any network device, whether it's a Juniper box, Cisco box, Linux box, Windows box, I should be able to throw all my syslog messages onto a NAPAM log, onto NAPAM logs, which will then give me a structured output. Example, please remember this syntax from Juniper and Cisco iOS XR, and with NAPAM logs, I get this syntax, the same error in a very structured manner. Doesn't matter which device it comes from, whether it comes from a Juniper box, Cisco box, Huawei box, Linux machine, Windows machine, I should be able to read my log messages in a structured manner. So that gives me a layer of abstraction. So once I have managed to extract this in a structured manner, then I should be able to feed this off to tools. I'm not a fan of orchestration tools, right? I like automation tools. I'm a big Solve fan. Just a quick look at Solve. Solve, you have concepts of masters and minions. Many people tell me, oh, Tashi, Ansible does not have agents. Ansible is agentless. Salt is agent-based. Yes, that's why I like Salt, because then I can react to an event. Ansible, you can't react to an event in my network. I'll show you why. So Salt, you have master and minion. The problem with master and minion is you need to run the minion on the box, and many routers and switches will not allow me to run a Salt minion on the box. So Salt has come up with a technique called proxy minions, right? Where I don't necessarily have to run the minion on the box. Instead, I run proxy minion somewhere, and I'm able to pull information from my network devices, either through the netcon protocol, SSH, or HTTPS, whatever you like, right? So that log message that I talked earlier, where you have now in a structured NAPAN log, now I could feed it to a tool like Salt, right? And then Salt has the Salt event bus. Once I pull it there, then I can fully automate. I can fully automate my network, right? I can fully automate my network. Let me show you how I can automate my network. Here is the example. Here is the example. One of my device has lost its connection to its NTP server. That's the problem. That's the log I have received. Okay. That log message gets structured through NAPAM logs. It gets fed to my Salt event bus, right? Then my Salt master starts reacting automatically. I don't have to do anything, right? I define the state, of course. And then my Salt master, as you can see, it goes, hey, this device log message is saying it has lost connection to NTP server 1.2.3.4. Hey, minions, you need to go make the changes. And here the administrator is not doing anything. The Salt master is taking care of this, and it is instructing the Salt minions that we need to give this device a second or a backup NTP server. Look at the log. This is the first log, and this is the second log, where it's happening automatically there, right? In the second log, it's saying, since you can't reach 1.2.3.4, I suggest you try a different NTP server, right? So it is saying, okay, it can't reach 1.2.3.4. I want you to now try and connect to this other NTP server. The new NTP server is 17.2.3.2.125 without me having to do anything, right? And this, once it has found that, this is the config it is automatically pushing based on that event that I received from this device, where this one is saying, okay, you lost connection to NTP server 1.2.3.4. Please connect to NTP server 17.253.2.125. It automatically pushes that, and the device is back fully synchronous. Right. So I'm sorry if I rushed, because I wanted to listen to any questions, or maybe Essa, for you to summarize everything on my behalf and tell the crowd, because if I go slowly, I can just take so much time. But I wanted to give this story about, don't think of coding the network as a programming thing. It's more architectural framework. You need layer of abstraction. You need to think of event-driven automation. Don't go crazy with orchestration tools, right? Automation is not only about configuration management. It's about the ability for me to dictate the state in the network that I want. Thank you so much.
Thank you, Tashi, for your excellent explanation. And it was really an inspiring session. So I believe you moved the network engineers like a boat in the sea with your ideas and a lot of interesting topic you mentioned. I think you completely somehow put the ideas like in a totally different or opposite way of like normally the people in the way they are thinking. For example, if we look at the back stories, people were just struggling with the normal CLI commands. For example, they were more dependent on the specific vendors. For example, Juniper and the Cisco, they were leader of the market. Maybe they are still leader of the market, but we cannot say. Even these companies, I'm sure they are more going to the open source. Even they are putting in their core components of their technology, the open source. For example, their switches. I can tell you more, the OS exists when the things are not functioning, and I can say, for example, Cisco is coming and making a changes, and it is dev shell, which is of course an open source, I can say. So, dear audience, if you have any question, please post I have some not question, I can say, like I have a message from Tilla Hashimi. He said, I have spent considerable amount of time learning to manage devices via CLI. Now you're saying CLI is history. I think still it's a power of the CLI, but while we are coding.
Let
So
me
let's
let
first
me
take
take
the questions of the audience, then I will
yes.
have my own
Yes.
question if we
Yep,
have
Issa.
time.
Let me take that because that's a very important comment. Please, do not think your knowledge of CLI is no more useful. Do you guys remember the big Facebook outage a few years ago? They had fancy automation engineers who could automate way better than you and me combined ever, right? But when the outage happened, the two engineers who reached the site did not know CLI. They did not know BGP. They did not know the CLI. So they couldn't fix the problem. It should have been fixed in 5 minutes, right? But it took almost 4 hours for them to fix, and about 3 billion users were not able to connect to that service. So I don't know whose question that was, but please, what I was saying was not that your CLI knowledge is not important, not that your protocol knowledge is not important. That fundamental will never change. You need to be able to jump on the box, take control through a console or whatever, and fix the problem. This was assuming everything is working well, and then for you to be able to manage your network at a scale, then there are tools, right? You can't always, if you have one router in your network, great. But if you're Reliance Jio, they have 250,000 core routers. China Unicom might have 1 million routers. Are you going to be on the CLI of all those 1 million routers to fix the problem? Right? In that case, you need some scalable method of doing it. But Tala, you will never lose your knowledge. That knowledge that you have will always be crucial. Please, that's all I want to say.
So there is another question from Mr. Hussein Wahidi. What is the difference between NFV and SDN?
That's a very interesting question. They are complementary, is what I would say, right? Again, NFV, you need to think of this, right? NFV came from the operators. NFV was not a vendor push. NFV came from operators like you and me who say, "Hey, I'm fed up running, paying you so much money for this expensive box, $1 million for a big box." So they said, are we able to run certain things on, let's say, off the shelf commercial product, right? So that was the idea of NFV. But again, you see, NFV's idea is great. Operators pushed it. Some people even call NFV new feature velocity, not network function virtualization, because you want to deploy new features as quickly as possible. I don't have to wait for Issa, for example, if Issa is the product lead for Cisco, I shouldn't have to wait for Cisco to release that in their next product, a feature that I want now, right? So that's why the operator said, no, you cannot control the game. I need to deploy the feature yesterday, and you are telling me wait for next 2 years for me to release the new product. So NFP comes from that idea, right? That can I run an OS on a off-the-shelf commercial tool? But please be careful. Like I said, no, none of us have mastered. I have run on bare metal. I don't know how many of you have used bare metal devices, Tofino, bare metal devices, or Facebook's blue boxes, data plane. How many of you use Microtech in your network? Right. Microtech was that first idea where, okay, I'll run an operating system which we called Router OS those days. It was an open source tool. They ran it on a hardware, but they still can have not mastered the data plane, right? It's only few vendors who have mastered the data plane. While NFV is a great idea, reality is very different. Right? So they are complementary. SDN and NFV, I would say they're complementary.
I can also share the real story why people or network engineers they should not depend on the vendor. For example, there are some countries, for example, they are banned, so they cannot get support from the vendor. For example, Cisco. Let's
Yeah.
let's 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 consider Iran. In the Iran, I really call the network engineers are a champion because they are not able to get any support if there is a bug, if there is any issue with the software, with the hardware. So they have to sort it out. It's really
Yeah.
an example we can
Yes.
say.
Yeah. Yeah.
That's
Correct.
when it comes like your the power of understanding the basis and the neutral technology. So we can consider. Okay.
Yes.
So any other question? Let me. I
Sorry,
see
Issa.
that disorganized. Let me.
Sorry, I was just trying to type. Hussein had said, "Oh, NFV is network function virtualization." Yes, it's Hussein. I know that, but I was saying that some operators generally call NFV not network function virtualization. They call it new feature velocity because the whole idea is of NFV was, can I release a feature as soon as possible, without waiting for vendors to charge me $1 more million. Example, I don't know how many of you I have talked with about IPv6 deployment in mobile networks. Some vendors charge you a license fee for IPv6 PDP, right? So you shouldn't have to wait for those things.
Thank you, Tashi. Okay. And also say briefly about server-side technology like Docker and Kubernetes.
Okay, a quick one. Okay, don't call it Docker. I come from the Unix world, right? In Unix, we called it jail, right? You call it Unix jail. Then came Linux jail. Then people came up with LXDs. Then people came up with LXCs, right? Those were the first container concept. And it's a jail concept, right? Problem with jails, I can break out of a jail for real, right? That's the problem with containers. So then Google and few other people, because they want to run microservices, because it's like if there is a big demand, they should be able to spin up 1 million containers in no time. Once the demand dies, they should be able to kill all those 1 million containers in no time. So that was the whole idea of jails and containers. So that's what Docker is. And Kubernetes just helps you manage those clusters of those Dockers, right? It's a very long, if you want me to go in detail, maybe Mohib, I'll try to assign Mohib, maybe we should write a tutorial one day. I'm happy to run a virtualization
Yeah, we
tutorial.
can maybe in the future we can dedicate a session for some specific
Yeah,
topics such as like this.
yeah.
So we have 5 minutes more. Audience, if you have any question, please post in the chat.
Yeah, but thank you for the questions. At least someone
Yeah,
is
I
listening,
think
someone is
we can
thinking.
go for some more generic question.
Yeah, yeah. Happy to chat.
These questions may be addressed from by myself. So
Yes, yes, please.
okay, before that, let's go back to another question. Containerization, Kubernetes, and Docker is a big topic that might take. Okay, it's by Atiqullah, our colleague. So he also mentioned about the dedicated session. Okay, Toshi, what you suggest if you teach us coding your network? So what will be the starting point, for example? We should first start with the CLI, or we should start with the learning some programming language, or again go to the SDN network.
Very good question, Issa, and there is no straight answer. I think why you're saving the question to the last. I like what my friend Mersh here from Cloudflare and DigitalOcean says. For me to automate my network, I don't need to know a programming language. If you know it, great, because the framework, you know the frameworks of and for me, programming is problem solving, right? Example, I speak a bit of Hindi, a bit of Nepali, a bit of Japanese, a bit of English, doesn't mean that she can write a novel, right? Just because I know a language. So me knowing a Python does not mean I might be a good problem solver, right? Many people, yeah, I do Python, I do Lua, I do shell scripting, but I will never be able to develop a good software. That is there, right? So let us not confuse. So for me, if you want to go into coding the network, first and the most important thing is what Dr. Philip always says, fundamentals are crucial, right? If I don't know BGP, what do I code? What do I inject? I have no idea. What state do I push? If I don't know IGP, What do I even understand about topology discovery? So fundamental knowledge is crucial. If you don't even know IPv6, how are you going to do SRv6? Right. That's my point. And there are many vendors who say, "Oh, do segment routing, but over MPLS." Why? Right? MPLS is a hangover from the telecom world for vendors to make more money. Example, right? It's a license-based feature that I need to do. But my point is, you need to know the fundamentals. Again, Mohib and me. I'm sorry, I keep using Mohib because I was just last week with him in Germany. So Mohib and me, we were talking that I only read RFCs. I have never read one vendor book. I'm not CCNA certified. I'm not CCNP. I'm nothing, right? But do I know how to build a network? Sure, I know. Do I know how to script? Yes, I know. Do I know how to automate a network? Yes, I know. Right? Do I know how to deploy V6? Yes, I deployed V6 in 2007. I deployed RPKI in 2013 and 14. One of the very early deployers of fundamental technologies. And it was all thanks to my mentors like Randy Bush, Dr. Philip, who said, Tashi, if you have time, break the network, do something stupid, learn from that. So
Thank
fundamentals
you.
first.
I
Yeah.
got the answer. So I think it's really important to have the knowledge of a technology in depth, for example, and then you can play with that and code it. So as an
Yeah.
instructor, and I'm a authorized instructor with the Cisco and with the CompTIA, for example, the two famous vendor. I always suggest my students don't rely on Cisco. Why I more prefer the CompTIA? Because they are talking about the neutral technology, not specific to the vendor. So I think we have one more minute, and unfortunately, we don't have much time, and the time was
No,
very short, and I still have a lot of questions. So I think
I,
we'll have another session. We will deep dive again. So thanks, Utmat Khensep.
Thank you
thank you
very
so
much,
much.
Tashi. It was a really interesting discussion. Thank you, Rahimi Saib, for moderating this session. Uh, um, it was interactive, and we as listeners enjoyed and learned. And I hope that our participants have also enjoyed and learned from the presentation and the discussions. With this, we come to the end of our first day of Afghanistan Network Operators Group 2 meeting. And I thank everyone who joined us today. تشکر از اینکه با ما بودین تا این لحظه را. برنامه برای فردا دوباره از ساعت 1 بجه شروع میشه. روز دوم ما پنل دیسکشن داریم و تاپیک های بسیار خوب دیگه که فردا بخیر او سشن ها را خواد داشتیم. امیدوار هستم دوباره فردا همه شما را آنلاین ببینم و چیزهای زیادی برای بحث کردن و دیسکشن فردا انشاءالله خواد داشتیم. تشکر از اینکه با ما بودین. وقت همه بخیر. Thank you Tashi. Thank you Rahimi Saib. Thank you all.
Thank you. Have a great time.
Yeah.
Thank you so
Have a
much.
nice time,
Thank you.
everyone.
Yeah. Take care, everyone. Bye.